Alright, in this video we're doing 4.3b. It's probability again, but this time we're talking about Venn diagrams. Two-way tables can be used to illustrate the sample space of a chance process including two events. So can Venn diagrams. Same information, just a different way of showing it. A Venn diagram consists of two or more circles surrounded by a rectangle. Each circle represents an event, and the region inside the rectangle represents the sample space of the chance process. So here's a generic Venn diagram. See event A and event B, and the overlap is where both of them are true. And this rectangle around them gives you this free space, this lighter yellow color, where neither of them are true. So in the previous example, our events of interest were A is male, B has pierced ears. So here's a two-way table that describes or summarizes this data. So A is male, B is pierced ears. Okay, so A is male, not A is then female. B is pierced ears, and not B is not pierced ears. All right, so here's our circle. A is male, B is pierced ears. So the blue is the pierced ears, the yellow is male or not male. So here's how we break this down. The intersection of the two circles is the male and the pierced ears. And honestly, when you fill out a Venn diagram, you always start with the overlap. Okay, so this 19 right here, we start there. We put that in the intersection. Okay, then inside circle A, but outside circle B, what's left in circle A is those that are not male but have pierced ears, which is 71. So if you didn't know the 71, you would take the total of all the males, which is 90, and subtract 19, and you would get 71. Now on event B, pierced ears. Okay, we already took 19 of the people who were pierced ears, which was a total of 103, right? 103 is my total. So I took 19 already in the overlap. So what's left when I subtract those 19 is the 84. But we already knew the 84 right here in the table. If you don't have the table, you can still figure these numbers out. That's what I'm getting at. Okay? So there's where the 84 came from. There's where the 71 came from. And then if you add these all up, you have the not males and the not pierced ears, and that's the 4. Okay, if you weren't sure of that 4, if you didn't have the table, you would add up the three numbers you have, 71, 19, and 84, and then you'd have some value, and you would subtract it from the 178, and what's left is the 4. So I'd end up with 174 when I added them all up. 178 minus 174 leaves me 4 that are then female with no pierced ears. Okay? So you're going to have some practice today making your own Venn diagrams. Some standard vocabulary and notation have been developed to make our work with Venn diagrams a bit easier. So the complement of A, AC, contains the outcomes that are not in A. Okay? So if A is the white circle, the green is the complement of A, everything that's not A. The event A and B is called the intersection of A and B. The corresponding notation is this upside down horseshoe, and we read it as A intersection B, and it's the overlap of the two circles. The event A or B is known as the union of A and B, and the corresponding notation is A with a U and a B. That's not really a U because you don't put that straight stem on it, it's just the right side up horseshoe. A union B is what you say, and then look about the diagram, it's all of it, the overlap and the non-overlapped parts. That is the union of A and B. So here's some definitions, you need to write these down. The event A and B is called the intersection of events A and B. It consists of all the outcomes that are common to both events and is denoted A intersection B. The event A or B is called the union of events A and B. It consists of all outcomes that are in event A or event B or both. It is denoted A union B. With this new notation, we can rewrite the general addition rule that we talked about in our last video as this. We say A union B is a probability of A plus probability of B, subtract the probability of A intersection with B, and that's the overlap, if you will. Okay, nothing new, Same process we've done before, we just have new symbols for it. Instead of saying or, we use the right side up horseshoe. Instead of saying and, we use the upside down horseshoe. So here's a type of problem you'll see. According to the National Center of Health Statistics in December 2012, 60% of U.S. households had a traditional landline telephone. 89% of households had cell phones, and 51% had both. Suppose we randomly selected a household in December 2012. What's the probability that the household has a traditional landline telephone or a cell phone? A. Construct a Venn diagram to represent the outcomes of this chance process using these events. T has a traditional landline, and C has a cell phone. So we have two circles, we've labeled our two circles, and then we take our information from the stem of the problem and figure it out. Now notice these are percentages, okay? Percentages, you're going to make them decimals when you put them in a Venn diagram. And you always start with the overlap of the two, all right? So I'm going to start with the 51% that had both cell phones and landlines, and that's the overlap in the drawing, okay? So I'm going to make it 0.51. Now the next thing I would look at is the 60% that of U.S. households had a traditional landline, okay? So 60% make up this whole circle right here. Well, 51% has already been taken up in the intersection. So I take 60.6 and I subtract 0.51, and that's where I get the 0.09. Then I look at the next thing it tells me. 89% of the households had cell phones. That's this whole circle. Has to add up to 89%. I already know the 51% is counted for, so I take 0.89 and I subtract 0.51 and I get 0.38. Now, I always make sure that all of these add up to 1 because all your probabilities have to add up to 1. So I take 0.09 plus 0.51 plus 0.38. That doesn't quite add up to 1. It adds up to 0.98. So that means 0.02 is left. So I got to include that 0.02 in my sample space out here, where that means they don't have a landline, nor do they have a cell phone. Okay? So then I've completed my Venn diagram. That's A. B says, find the probability that the household has a cell phone only. So I look at my cell phone circle. And I want cell phone only, so I do not want this overlap of cell phone and landline. I just want the cell phone one only. That's where I get the 0.38 that I have in my answer. Okay? So Venn diagrams are extremely helpful. You just got to be real careful when you create them. Okay, here's another example. Construct a Venn diagram and answer the following. A survey of couples in a city found the following probabilities. A, the probability the husband is employed is 0.85. B, the probability the wife is employed is 0.6. And C, that the probability that both are employed is 0.55. So again, you start with your two circles and your rectangle that borders them. And I would start with the intersection of the two probabilities, okay? So this is the intersection statement right here. Probability that both are employed is 0.55, so I start there. And then I kind of go back to the beginning. What did it tell me first? The probability that the husband is employed is 0.85. So if I make the circle on the right husband, I know that these two probabilities have to add up to be 0.85. So I take 0.85 and I subtract 0.55 and I'm left with 0.30. Then I do the same thing for the wife. It says the probability that the wife is employed is 0.6. So I know that these two probabilities have to add up to be 0.6. So I already know 0.55, I subtract it, and I'm left with 0.05, and that's where I get 0.05 for just the wife that is employed. 0.55 is still that both of them are employed. Now I can answer some questions about this. So a couple selected at random. Find the probability that P, at least one of them is employed. At least one of them is employed. So what I would do is take my two wife probabilities of just the wife being employed and the husband being employed, and I get 0.05 plus 0.3, and I get 0.35 when I add them up. Okay? Number 2, probability that neither one is employed would mean I would take all three of these probabilities on my Venn diagram because these three in the circles represent somebody's employed. Add them up and subtract them from 1. So I have 1 minus, and then this is the sum of the 3. Okay, 0.5 plus 0.55 is 0.6, plus 0.3 is 0.9. So 1 minus 0.9 gives me 0.1. Now, if you remembered in your sample space to do that extra value that was outside the circles, then you already calculated this. If you didn't, then this is asking you to do that. What's the probability that neither employed? It's that 0.1, the value that sits outside. Hopefully this gives you a good format to follow as you work on your problems.